Now we'll try to apply the SSS and SAS theorems. So we want to determine whether triangle RST is similar to triangle ABC. On number one, here's what we can do. We can try to see if all the corresponding sides are in proportion. So the easiest way to do that, in my opinion, is take a look at like the shortest side of triangle ABC, 2.5. Then that would correspond with the shortest side of triangle RST, which is 4. So the ratio of 2.5 to 4 has to be the same as the ratio of the middle side in triangle ABC is 5. The middle side in triangle RST is 7. And then that has to be the same as the longest sides, 6 and 8. So if all of these are true, a true proportion, then the triangles would be similar. One way to check it is to cross multiply. So if I just take a look at two ratios set equal to each other at a time, not all three, if 2.5 times 7 is equal to 4 times 5, then that would be a true proportion. Here's another way that you can do it. Just divide 2.5 by 4. That's the same as 5 divided by 7 and the same as 6 divided by 8. Then those two triangles would be similar. The way that I did it then and showed the results of is just dividing 2.5 by 4, 5 by 7, 6 by 8, came up with these decimals. None of them are the same. So these two triangles, RST and ABC, are not similar. Okay. And then you could do something along the same lines on number 2. So in order to do that, 2.5 would correspond with 1. Okay. 2, the middle side would correspond with 5, and then 6 would correspond with the 12/5. And I can simplify each of them. Well, 2.5 divided by 1, 2.5. 5 divided by 2, 2.5. And then 6 divided by 12/5. If I just wanted to do that without a calculator, if you divide by a fraction, that's the same as multiplying by the reciprocal. So 6 divided by 12/5 would be the same as 6 times 5 over 12. And then if I multiply there, 6 times 5, 30, divided by 12 is actually is actually 2.5. So since all of these are the same, then the two triangles would be similar, specifically by side similarity. On example 3, I want to find the values of x that make the two triangles RST and HGK similar. So RST has to be similar to HGK. Then we could set up proportions. So RS, if I look at the similarity statement, has to correspond with HG, 3 over x plus 7. Then we could set that equal to ST, this side right here, has to correspond with GK. ST are the last two letters of the first triangle. GK are the last two letters of the second triangle. So that would have to equal 5 over 23rds. And then in order to solve this, I can cross multiply. 3 times 23rds is just going to be 20. That should equal 5 times a quantity, x plus 7. So it's important to have parentheses there. You could distribute here. 20 is equal to 5x plus 35. If I subtract 35 from each side, negative 15 is equal to 5x. So x is equal to negative 3. Find the value of x that makes those two triangles similar. We just did. If I substitute in negative 3, you might say, well, you can't have a negative value of x. You actually can, because negative 3 plus 7, that's positive 4. You can definitely have a side length of 4. And then 3 minus negative 3, if I substitute in x here, that'd be the same as 3 plus 3, 6. So the value of x is equal to 3.